Okay, hi folks. This is the second video segment. We got interrupted when I was doing problem number 31. So let's go try that. So this is number 31, cotangent of minus pi over 4. Now I did mention that in class we discussed the facts that a sine, uh, a tangent, and cotangent are all odd functions. And what that means is that cotangent of any one of these actually minus theta is the same as minus cotangent of theta. Okay, so the minus basically comes out for any one of these three functions. That being the case, I can write this thing as minus cotangent of pi over 4. And I want to remind you that cotangent is cosine of pi over 4 over sine of pi over 4. And notice that these are both the same at pi over 4, and this is equal to minus 1. Okay, so that takes care of number 31. Let's go ahead and do number 32. 32. Okay, 32. What have we got there? Cosine of 7 pi over 4. Now, for example, we can write this thing as cosine of 2 pi minus pi over 4. And because cosine is periodic of period of 2 pi, so this is the same as cosine of minus pi over 4. And cosine is an even function. Remember, by the way, up here, before I go and do the cosine one, I want to remind you that cosecant, because it is 1 over sine, is also odd. Now, as far as cosine and secant, these are even functions. Therefore, this minus sign can be completely dropped out. Remember, even means that cosine of minus theta is the same as cosine of theta. That being the case, I can write this thing as cosine of pi over 4, which we know what it is root 2 over 2 over 1 over root 2. By the way, I want to point out that some of these problems that I did, I drew the unit circle because I wanted you to become familiar or review the concept of what is this reference angle and things like that. Yeah, I mean, but if you don't have to, you don't have to go that route. So in these problems, I feel it more convenient to use the fact that we know something else about these functions. So tangent of 5 pi over 4, okay, as I'm going to write this thing as tangent of one way to do that is to say tangent of let's see, for example, a pi plus pi over 4, right? And let's recall that tangent x and cotangent have period pi, not 2 pi, period pi. Remember, the period of tangent of, in general, tangent of kx was period was equal to pi over k. Do you remember that? So when k is 1, like in when I talk about tangent of 1x, period is pi. So this being the case, I can go here and write this thing as tangent of pi over 4, and hopefully we all remember tangent of pi over 4 is 1, because it's sine of pi over 4 over cosine of pi over 4, and they're both same thing, root 2 over 2. Okay, so let me do another page. Where we go? Right there. Number 33. we have tangent of 5 pi over 2. I'm going to write this thing as tangent of 2 pi plus pi over 2. But the period of tangent is pi, therefore I can immediately write this thing as, and this is 2 pi, that's double the period, that's okay. Tangent of pi over 2. And tangent of pi over 2 is, remember, cos pi over 2. Oops, sorry, sine pi over 2 over cos pi over 2. And cos pi over 2 is 0, so this is undefined. All right. The other way to remember what happened, it's a good review, so I'm going to do it like that too. So where is this draw? If you go back to the graph of tangent, it was like this, right? Pi over 2, vertical asymptote, minus pi over 2, vertical asymptote, and the period you can see is pi. So the next one is going to be 3 pi over 2, vertical asymptote. So the curve goes like this, the curve goes like that. And of course, the next one is going to be 5 pi over 2, and the function goes like that. So at 5 over 2, you can see that the function shoots to infinity. Last one from this group of problem, number 34. Sine of 11 pi over 6. So I'm going to write this thing as sine of 2 pi minus pi over 6. And the period of sine is 2 pi, so immediately I can write this thing as sine of minus pi over 6. Because when you add the period to it, the value will not change. And this sine is an odd function, so the minus comes out. And this is, of course, 1/2, minus 1/2. Okay, so let's move on to the other problems. I don't know how I get to these pages, so let me see. This entire page, I want to delete these pages. Okay, I see. I'm having a problem deleting entire pages. Select, let me see for a second. Oh yeah, okay. Let's go down. Then delete. Okay, we're up there. All right. Now these type of problems we have already done when we were doing chapter 2, discussing unit circles, etc. It's the same type, it's just that I don't know. It appears here in this section. Find the quadrant in which theta lies. So we are looking at, which problem is this? Okay, we are looking at 35. It says if sine of theta is negative and cosine of theta is negative, in what quadrant is the angle theta located? All right, so let's see now. Here's a trick circle if you want. So I don't have to draw the circle, but there we are. This is quadrant 1, here's quadrant 2, there's quadrant 3, and this is quadrant 4. Now, because sine of theta is negative, just look at your xy axis. Negative means sine of theta negative means that you are down here somewhere. The vertical axis, remember the vertical one is sine, the horizontal one is cosine, and if sine is negative, you're down here. And the fact that cosine is negative, it means that you're in this piece. Where is it that they both are true? It is quadrant 3. Okay, so the answer would be quadrant 3. So what I expect you to do on the test, to write, or a quiz, to write these things. Sine theta negative implies that we are in quadrant 3 or 4. cos theta negative implies that we are in quadrant 2 or 3. Therefore, we are in the common quadrant 3. If you came and as the answer to this problem just wrote this thing for me, you would not get marks. You would not get full marks. You get very little marks. You need to justify. You need to justify. This is a mathematical. Statement. Okay. So what else is not acceptable? Okay, you write the answer, no problem. Without the drawing, you don't draw anything for me. I have no idea what you were thinking, and then you just come back and don't even write these things. Okay, if you don't write these things and just say sine is negative, cosine is negative, the answer is 3. This is not acceptable because you're just repeating what the problem told me. Okay, all right. Let's look at the next one. So let me try to write this the way I want it to be answered. This is number 36. Tangent theta negative. Now, if you memorize this thing, I don't know, it's up to you. If you memorize where is it, the answer was we are in quadrant 2 or 4. Negative tangent in quadrant 2 or 4. Okay, this is acceptable. Okay, and a sine of theta negative. We just discussed this thing up there. We are in quadrant 3 or 4. There's a common. Therefore, theta is in quadrant 4. Oops, what happened here? Right there, quadrant 4. Now, basically, show me some. Uh, this could have, by the way, been in the form of the figure. In other words, we could have set tangent of theta negative. Okay, you're here, you're here. Sine of theta negative means that you are either on a separate graph or on the same figure, it doesn't matter. You're down here, and the common area, yeah. So you can see that common is quadrant 3. Did I say 3? So I'm going to go and fix this thing here. There seems to be something wrong here. Tangent of theta negative, this is correct. Sine of theta negative, you are in 3 and 4, 3 or 4. The common is there. So let me see here. What did I do? Right, this is a mistake. This one is a mistake. My mistake. Bad mistake. Clean it up, please. This is not correct. When it came to drawing, I didn't do a good job here. This is in quadrant 2. You're either here or there. Okay. And the common, of course, is quadrant 4. This is wrong. This was wrong. Quadrant 4. Okay, good. Move on. Insert new page. How is it that it keeps putting it at the bottom? I'm not sure. Okay, so let me insert some pages here. Okay, let's go all the way to the top. All right, what do we got here? We did these two. We go to problem number 39. Okay, 39. It says, let me see, write the first trigonometric function in terms of the second one, considering the fact that you're given you're in certain quadrants. So 39, the idea is this. I want tangent on the left. Okay, I want tangent here, tangent of theta here, in terms of cosine, only cosine of theta on the right hand side. Only cosine on the right hand side. Okay? And pick the correct algebraic sign. When you'll see what I mean in a second. We did problems like this on numerous occasions. Okay. So first of all, tangent of theta is sine of theta over cosine of theta. And since we want only cosine on the right-hand side, then immediately you write down one of the most important identities in trigonometry. We talked about this thing in class several times. Now, because you are in quadrant 3, that means tangent must be negative. And if tangent is negative, the now remember, quadrant 3, tangent is negative. Of course, cosine of theta is positive, is negative, right? Of course, cosine of theta is negative in quadrant 3. Okay, I made a mistake here. Quadrant 3 means tangent is positive. Big mistake. Big mistake. Quadrant 3 means tangent of theta is positive. Of course, we know in quadrant 3 cosine of theta is negative. So in the top, in the numerator, you have to pick the correct algebraic sign such that it makes the entire ratio a positive number because of this. So the correct answer is tangent of theta equal to minus square root of 1 minus cosine squared theta over cosine of theta. Notice that there's only cosine on the right hand side. The thing on the top is negative because of this minus sign, and the thing in the bottom is also negative because you are in quadrant angle theta is in quadrant 3, and quadrant 3 has a negative cosine. So the whole thing is a positive number as expected. Okay, let's go and do the other one. Similar. This one is 40. So cotangent must be written in terms of sine only. In terms of sine only. Okay? And by the way, we are told that the angle theta is in quadrant 2. Just remember this, quadrant 2. Okay. Now, so first of all, we know what cotangent is. Cotangent is cosine of theta over sine of theta. And the top plus or minus square root. Plus or minus square root of 1 minus sine squared theta over sine of theta. Okay? Now, notice that the right-hand side right now only has sine in it, which is great. But now we are told that we are in quadrant what is that, quadrant 2. We are told that in quadrant 2, let's think about it. Quadrant 2 is right here, correct? Okay. Now we know in quadrant 2 the only place where cotangent and tangent are positives are quadrant 1 and 3. So cotangent of theta is negative. The only place where tangent and cotangent are positive are 1 and 3. Okay, so because we are told that we are in quadrant 2, cotangent is negative, but over here you can see that sine of theta is a positive number in quadrant 2. That means this ratio, the sign must be picked so that the entire fraction becomes negative. Obviously, we need this minus sign. So cotangent of theta equal to minus square root of 1 minus sine squared theta divided by sine of theta. Does it make sense? The entire right-hand side is only sine, as we expected. The fraction will be negative because the bottom sine of theta is a positive number. You're in quadrant 2. And the top, the minus sign is picked. That means the entire ratio becomes a negative number. Let's go and do 41. 41, cosine in terms of sine. So on the right-hand side, only sine. So obviously we know how it works. Square root of 1 minus sine squared. However, we are told that you're in quadrant 4. Now quadrant 4, remember, this is 1, 2, 3, and 4. And quadrant 4, we know cosine is positive, right? So of these, you have to pick something that'll give you positive cosine. Quadrant 4 means that cosine is positive, and therefore the answer is cos theta equal to plus square root of 1 minus sine squared. That's how we do these problems. All right, so the next one. Okay, so it says that number 45, same type of problem, except that now you have to do it in terms of the numbers. So let's go here. Okay, so let's do 45. You are in quadrant 2, and sine of theta is given to be 3 over 5. You're asked to find all the other trig entities. Now, immediately we have cosecant of theta equal to 1 over sine theta, which is 5 over 3. Okay? Now, let's find the cosine. Cosine of theta is equal to plus or minus square root of 1 minus sine squared. But we're told sine squared is this number. So plus or minus square root of 1 minus 9 over 25. This is square sign. And this is plus or minus. If you do the algebra, you get 4 over 5. Now, quadrant 2 implies that cosine is negative. That means the correct algebraic sign is actually minus 4 over 5. So this is cosine, this is cosecant, and of course sine was given to us. Now immediately we write down secant of theta is 1 over cosine of theta, which means 1 over minus 4 over 5, and that means secant of theta is equal to minus 5 over 4. Let's do tangent. Tangent of theta. Now, since we found sine and cosine correctly, hopefully with algebraic sign, so this is going to be sine of theta over cosine of theta. Sine of theta was given to us. It was 3 over 5, I think, yeah. Cosine of theta, we just found it, minus 4 over 5. And this is going to be minus 3 over 4. Okay, and that's good because let me write it here, tangent of theta equal to minus 3 over 4, because in quadrant 2 and quadrant 4, tangent and cotangent are both negative, and this actually got it. If we had made a sign error, algebraic sign error here, and we would have thought about this thing, we would have picked it up at this point. And cotangent of theta is just 1 over tangent, so the inverse of that. So there, minus 4 over 3. Notice that these problems are the same as the one in the previous box, except that you have specific numbers for it. So let's do 46. We are in quadrant 3. That's good. And we are told that cosine of theta is equal to minus 7 over 12. Okay. Now, immediately, you have secant of theta, 1 over cos theta is equal to minus 12 over 7. No problem. Now, let's do sine. Sine of theta equal to plus or minus square root of 1 minus cosine squared theta. And this is going to be plus or minus square root of 1 minus 7 over 12 squared. And this is going to be plus or minus square root of 144 minus 49 divided by 12 plus or minus square root of, there's a 5 here, 9 of 14 is 5, 95 over 12. Okay, there's really not much you can do. And if you're asked to find the exact value, don't try to put the stuff in the calculator. Here it doesn't say so. So exact value, you can presumably find this thing in your calculator and turn it in decimal. I don't want you to do it. Just leave it like this, please. The only thing is that which one of these. Now, quadrant 3 implies that sine theta is negative, and therefore the correct algebraic sign is minus square root of 95 over 12. There we are. And immediately cosecant of theta is going to be 1 over that. So it's going to be minus 12 over square root of 95. We now have to do tangent and cotangent. Tangent of theta, assuming that we have done the algebraic signs here, is sine theta over cos theta minus root of 95 over 12. And cosine was given to us, minus 7 over 12. And this is root 95 over 7. Good sign, because we are in quadrant 3, tangent and cotangent should be both positive. And of course, cotangent of theta is equal to 1 over that, which is 7 over root of 95. I hope that I didn't make an algebra error with this 95. I don't think I have, but you never know. Okay, let's do the next one. 47. We are in quadrant. We are not specifically told what quadrant we are in, but we are told that cosine of theta is positive. And now, of course, that means cosine of theta positive means that you're in either quadrant 1 or quadrant 4. Okay, so although it's not explicitly, we are not explicitly told, but we know one or the other. Okay, so what do we want here? We are told that tangent of theta equal to minus 3 over 4. Okay, this is given to us, so immediately cotangent of theta is equal to minus 4 over 3. I made a mistake here. What I meant here was 2. Okay, let's just be careful here. Let me see now. This was given to us. Tangent of theta minus 3 over 4 is given. Cotangent is also correct. Okay, there's no issue here. There's nothing that we have to resolve there. If, yeah. So if, yep, that's okay. No problem there. Right. And these things do not contradict that, because if your tangent is minus 3 over 4, you're either in quadrant 2 or 4, which is good, so it doesn't contradict that. Yeah, no problem. This is good. Now let's go ahead and find for example, sine and cosine. We are left with sine, cosine, and secant and cosecant. Okay, how are we going to do this thing? Let's write it like this. We know that the different ways of doing this, for example, you can write down, uh, let me remind you that we have this identity, secant squared theta plus 1 equal to tangent squared theta. Now, these are important. They're coming back. If you don't remember these, you have to go and uh, just see how we got them. And where did this come from? It came from sine squared theta plus cosine squared theta equal to 1, right? Let me say, why is this thing true? You write this thing, this we know. If you divide both sides by sine squared, you're going to get 1 plus, uh, so if you divide both sides by cosine squared, so divide both sides by cosine squared. So when you do that, over here you get tangent squared theta plus cosine squared is 1, and this is equal to 1 over cosine squared, which is secant squared, which means that I made a horrible mistake there. This is why some of these I don't always memorize. So let me go ahead and clean this up. Bad mistake here. Tangent squared secant squared. Okay, very good. So let's go ahead and do the rest of this thing. So this is minus 3 over 4 squared plus 1 equal to secant squared theta. That means secant squared theta is equal to, if you do this thing, you're going to get 25 over 16. That means secant of theta is equal to plus or minus 5 over 4. But remember, what is this thing? Cosine is positive. If cosine is positive, secant is positive because 1 over cosine. And that means secant of theta is equal to plus 5 over 4. And cosine of theta, of course, is 1 over secant. So it's going to be all 4 over 5. This we got. Very good. Let's find sine. Sine of theta equal to plus or minus square root of 1 minus cosine squared. So this is plus or minus square root of 1 minus 4 over 5 squared. This is equal to plus or minus 3 over 5. This is sine of theta. Now you have to decide which algebraic sign you have to pick. Now let me remind you that we have tangent given to us. Tangent of theta was given to us and it was negative. That means you are either in quadrant 2 or 4, right? Or 4. And cosine theta was positive. That means you're either in quadrant cosine positive 1 or 3. So the common thing is cosine positive 1 or 2. That's what I meant. That's not correct. Cosine theta positive means you're either in 1 or no, 1 or 4. Yeah, 1 or 4. Yeah, so right there. So the common is right here. See, tangent negative, you're either in 2 or 4. No problem. Cosine positive, you're either in 1 or 4. So if both of them are true, you are in quadrant 4, quad 4, right? And if you are in quad 4, sine is negative. So the answer for sine, is sine of theta equal to negative 3 over 5. And of course, cosecant is negative 5 over 3. All right. I'm going to stop this video clip here. We'll do the rest of them in a separate one. Okay, these problems require some thinking. You can't just jump and get your answers.